happened, but I was cut off. So, molarity is simply the number of moles over the number of liters, okay? So, when we want to know how concentrated something is, if we know how many moles are in it and how many liters are in it, we can easily find how concentrated it is. And concentration can just tell us if it's really weak. Like, so if I'm dealing with an acid, if I have a very weak acid with a very low molarity, it's going to be pretty weak. So it might not work as well, but it also might not hurt my skin if it were to touch it. As opposed to if it had a high molarity, which is a high concentration of that acid, it might work really well, but it also, I might not be able to touch it. It might automatically burn my skin off. Okay, so molarity is really important when you're comparing different acids. It gives you a way to look at those acids and say which ones are more concentrated, which ones maybe might be more dangerous to me. If it's a very weak, low molarity, I know how to be able to use it. Okay, so we're going to go ahead and work a couple problems like this. Okay, so all you really need to know is the number of moles and the number of liters to find molarity. So let's look at the first example. It says, what is the concentration? When you hear concentration, you think big capital M, molarity, moles over liters. That's what you think. What's the concentration of NaOH if there are 2.6 moles of the substance with a volume of 534? Okay, so I'm going to use my formula here. Number of moles over number of liters, okay? And I'm just going to plug my numbers in. So the first number is 2.6 moles. So I have 2.6 moles of NaOH. That's what my substance is, okay? And now I just need to know my number of liters, okay? So they gave me milliliters. I need liters. So from here on out, you can see in your example, they go ahead and do that for you. They take the milliliters and they convert it into liters. I'm not going to, in my notes and when I'm talking, I'm going to just automatically do that from here on out because you should already know how to do that by now. We've been doing that for a long time. So I'm going to go ahead and just automatically put that number in. So if you see a number going from milliliters to liters, don't be confused. I automatically did it, okay? So if I have 534 milliliters, if I move that decimal point, I'm going to get 0.534 liters, okay? So you're just moving it those decimal points, okay? So this equals molarity, how concentrated this is. So if I go ahead and divide, I'm going to get, and I have only 2 sig figs, that's another thing I'm not going to be going over a whole lot. You should know by now you can only have the lowest amount of sig figs when you're multiplying or dividing. So I'm just going to leave that out and I'm going to be rounding appropriately and putting the right amount of sig figs in. Okay, so I can only have 2. So when I crunch that through, I'm going to end up with 4.9 molarity. And keep in mind, molarity simply means moles over liters, which is this, moles over liters. So you don't have to put moles over liters because that's what molarity means. So this is your number, 4.9. So it's helpful because if I have this substance, NaOH, and I want to compare it to, let's say, HCl, let's say I had a 9.5 molarity of HCl. Okay? And I would say, ooh, this one's definitely more concentrated. Or what if I had the same NaOH? Okay, what if I had the same substance but different molarities? Well, I know that this one's going to be, it's probably going to work better, but I'm going to have to be a lot more careful because it's more concentrated, okay? So let's look at the next one now. So really we're just plugging numbers in. The only thing that we might have to do on the side is if they don't give us moles, we'll have to find the moles. They'll give us things we need to do to find it. Or if we don't have liters, we have to get liters. But otherwise, they're going to give us what we need, okay? So the next one says, if a student dissolves 124.3 grams of HNO3 in enough water to make 250 milliliters of solution, what is the resulting molarity? So you're looking for molarity. So right away, I'm going to put my formula up here. Molarity is number of moles over number of liters. Okay, so I'm looking for that. So I know I need moles and liters. Did they give me moles? No. but they did give me grams, and I can take that, I can use that, okay? So, the first thing I'm going to do, because I can more easily convert my liters, I'm going to go ahead and do my liters first before we hop into our moles, okay? They said 250 milliliters, 250.0 milliliters. So I'm just going to go ahead and mentally switch that, okay? So now I've got 0.25, and keep in mind there were 4 sig figs there, so I have to make sure that this matches, okay? Because that does matter. So that's my bottom one. That was pretty easy. So now I'm going to go back. I need to find my number of moles. So I'm going to take my grams, and this is nothing new. We've done this a lot in the other modules. So off to the side, I'm going to take my grams, and I'm going to switch it to moles. Okay, so I'm going to start with 124.3 grams of HNO3. HNO3. Okay, now I'm going to be converting. Okay, I know I'm going to have grams down here, and I want moles up here of this guy, HNO3. HNO3. So you can see I'm setting this up like how we always have, okay? The thing that I need to find is grams, okay? I need to know how many grams are there in 1 mole. Well, we've done this, okay? So we just take our H, our N, and our O3. I'm just going to draw my little arrows because that's how I've done it. And I take my number off my periodic table. So the atomic mass for this is 1.01. For nitrogen, it is 14.0. And oxygen is 16.0, but there's 3 of them. So I'm going to multiply that, which is 63. Oh, nope, not 63. It's 48. Okay? So if I add all of these up, I'm going to get 63.0. So that's, remember, that's my grams in just that molecule. So that number goes down here. So this should be all review. Once I do this, my grams cancel, and I multiply across the top and the bottom and divide. And I should get, let's see, 1.97 moles, and this is of HNO3, okay? So, you should see, now I've got my moles, my number of moles, got my number of liters, so now I can divide and find the molarity. So I'm going to go ahead and just divide that, and I end up with 7.88. That equals my capital M, my molarity, okay? That's how concentrated something is. So if they're asking you just to find how concentrated or the molarity of something, that's how you do it, okay? It's just this formula, but you just have to find the moles and the liters, and sometimes they don't always give it to you, but like this example, you can always find it with what they give you, okay? So go ahead and pause the video for right now and do on your own 10.7. There's going to be 3 of them just like this. Sometimes they'll give the exact numbers to you to plug in, sometimes they won't, okay? Alright, so hopefully that went well and you're able to do the molarity equation pretty easily. Okay, that's our first equation we're going to talk about. Now, the next thing we're going to talk about is, it has to do with concentration as well, okay? When you have that concentrate, if you don't want it to be so concentrated like your juice, what do? You put that in there, and then what do you add to it to make it not so concentrated? You add water, right? And we call that diluting it. You hear this all the time, okay? This is the process of dilution, okay? So when you have a substance, you typically just take that substance and dilute it to use it, okay? So if you have a lower, let's say you have a molarity of this, and you can choose between a 6.3 and a 2.3, okay? You would always want to choose this one because you can take that higher one and dilute it down to where you need to be, okay? And we'll talk about that in a little bit later. But dilution also has its own formula, and it's easy, okay? So I'm going to take this down. We're going to look at it. The purple one is the dilution, okay? So what this is saying is you take the first concentration or molarity, you multiply it by the first volume, which is in liters, and it's going to equal the second concentration or molarity and the second volume. Okay, M1 times V1 equals M2 times V2. Okay, so really, just like anything else, this formula, you're just going to be plugging numbers in and you're going to be searching for the one that's missing. Okay, so let's take a look at this. And this is in order to dilute a substance, an acid or a base. So it says a chemist wants to dilute 12.0 molarity HCl to make 500 milliliters of a 3.5 molarity HCl solution. How will he do this? Don't get caught up. Think to yourself, molarity. I've got some molarities, I've got some volumes. Let's see which is which. Okay, so the 12.0, he wants to dilute it to make it to a 3.5 molarity. So I can see right away that my M1 is going to be 12.0 M, and my M2 is going to be a 3.5 M. Okay? So I'm looking for my volume 1, volume 2. So let's look at our volumes now. They gave me a 500 milliliter volume. So you're just going to have to read it to see which one it is. Is it the before or the after? The chemist wants to dilute to make 500 milliliters of this solution. That's the end game. That's what he wants to make. So that's going to be your second volume, 500 milliliters. Now, right away, I notice I'm looking for my first volume, okay? What is that first volume that we need to solve for? So they said, how will he do this? We need to know how he's gonna dilute it, okay? So we just use our formula, M1, V1, M2, V2. So I'm gonna stick 12.0, and keep in mind, here, I'll just write it out. We're solving for V1. Hold on, really quick. I'm going to move these around. Here's M1, V1 equals M2, V2. I'm solving for V1, so I'm just going to algebraically move this. Okay? So now I know where to put my stuff in place. So I'm going to start with M2, which is 3.5 molarity. Volume 2, which is 500 milliliters. And if it doesn't specify whether you need liters, like this one, it had to be liters, so you had to change it. But if it doesn't specify your volume amount, you can use milliliters. You don't have to change it, okay? So we're going to leave that there, and we're going to put it over our M1, which is 12.0 M. Now, let's take a look at our units. Our molarities are going to cancel, and that leaves us with milliliters, which is good because we want that volume, okay? So if I crunch all of that, and I use my significant figures, I'm going to end up with 1.5 times 10 to the second milliliters. That's my volume 1. So this is my answer, but they say, how will he do it? So keep in mind, you're going to take your original solution, your 12 molarity, and you're going to dilute it with water until it reaches the 500 milliliters, okay? So that's how much original solution you're going to need. So that's what it's telling you, okay? So let's look at the second one. So we're talking about dilution. A chemist takes 2.5 liters of 5.6 molarity NaOH and dilutes it with enough water to make 10 liters. What is the new concentration of NaOH? Concentration. Every time you hear concentration, think molarity, capital M, capital M. So you're solving for capital M, okay? We just need to figure out which one. So it says a chemist takes 2.5 liters of 5.5 molarity and dilutes it. So those two are our first figures. So we've got M1 and V1. The first molarity is 5.6, and the first volume was 2.5 liters.